Hi everyone, this video is meant to be your starting point for bioimage analysis using Python in your Windows machine. It's designed for people coming from life sciences or other fields with little or no background in computer science or coding. You might want to try deep learning based image analysis tools like CellPose, InstanceX, Stardist, or simply run your first analysis pipeline in your local PC. But terms like libraries, Conda, GitHub, repositories, or virtual environments can feel fuzzy and it's not clear where to begin. In this tutorial, I'll walk you through the minimal toolset you need to start running and developing image analysis pipelines on your Windows computer. We'll begin with a short introduction to the most important concepts, and then I'll guide you step by step through setting up your first working environment. So we will cover three essential elements: virtual environments, integrated developer environments or IDEs, and version control using Git. Let's start with the concept of virtual environments. Imagine you own a house and want to do some renovation projects, maybe carpentry, plumbing, and painting. If you want to avoid surprises, it is also good to have a plan or a set of instructions on how to carry each job. In turn, each job requires its own set of tools. In programming, these tools are called libraries or packages. Since the jobs are so different, you'd probably organize the tools in separate toolboxes, so you don't get them mixed up. In Python, these toolboxes are called virtual environments. Each environment contains not just the right tools, libraries, but also a specific version of Python itself. And versions matter. Having a Hammer 2.0 is not the same as having a Hammer version 0.1. Newer versions usually have more features and fewer bugs, but sometimes an older version is required to make everything work together. This is normally referred as compatibility. Now imagine you're building something more complex, like a cabin. A simple hammer or saw isn't enough. You might need an electric saw, which itself depends on several smaller parts: a blade, a motor, and a battery. In programming, this is what we call dependencies, when one library requires other libraries to function. And just like tools, these dependencies often need to be the right versions to fit together. But where do we get these tools? From repositories, which are like hardware stores for software libraries and packages. The main Python repository is PyPI, Python Package Index, which you can access with a tool called pip. For scientific computing, we often need more than just Python tools. We might also need C++ or CUDA for GPU acceleration. These come from another repository called Conda-Forge in combination with other channels like NVIDIA. To fetch and install libraries from repositories, we use package managers like pip, Conda, or mamba. And on top of that, Conda and mamba can also create and manage virtual environments. So they are both package managers and environment managers. Pip, in contrast, only handles packages. In practice, many people use mamba to create environments and install most libraries from Conda-Forge. If a package isn't available there, or you want to manually edit some library versions, upgrade it, or downgrade them, you can install them with pip inside the environment you created with Mamba. Since 2024, new tools written in Rust have appeared. These go under the name of Pixie and UV. Pixie is similar to Mamba, and UV is similar to pip. They are faster at solving dependencies, but since most tutorials still use Conda and Mamba, we'll focus on those here. Just keep Pixie and UV in your radar. I will probably release a video tutorial on them once I get to test them a bit more. Now, let's go back to our renovation plan metaphor and see how a bioimage analysis project will look in practice. Suppose you have microscopy images of cells and you want to analyze them. Your analysis plan, your instructions, will be written in Python. To make it work, you'll call different libraries from your Python code. For example, for nuclei segmentation, you might call CellPose or Stardist. CellPose depends on PyTorch to run its transformer model. Then PyTorch depends on NumPy for array operations and CUDA for GPU acceleration. Stardist instead relies on TensorFlow to implement its unit architecture. For object detection, you might use a YOLO model from the Ultralytics library, which depends on OpenCV and PyTorch. All of these libraries, with their dependencies, get packed together inside a virtual environment, and that's your organized toolset for this particular project. So this is how a typical bioimage analysis workflow might look like. You start with an input image, you run your Python code that calls libraries like Stardist, NumPy, and TensorFlow, and then the result is a set of nuclei labels. Now, how do we actually run this code? We could do everything from the command line interface, but often we want a more user-friendly interface where we can edit, debug, and visualize results. This is where an IDE or integrated development environment comes in. Think of an IDE as the equivalent of Microsoft Word, but for coding. It lets you write and edit your code, run it, debug errors, open different files, and even connect to the repositories online. In bioimage analysis, for example, we might visualize data with Napari. So both input images and the resulting labels. We'll write our Python analysis code in a Jupyter notebook and choose the right virtual environment, our toolbox to run everything. To recapitulate, writing and running your code and choosing the virtual environment you do inside the IDE, and Napari, a Python library, allow us to visualize the results. Finally, let's talk about version control with Git. Instead of keeping multiple versions of the same file, Git is like a time machine for your code. It keeps track of every change you make, so you can always go back to an earlier version or compare what has changed. If you have used track changes in Word or version history in Google Docs, the idea is similar. Git also makes collaboration easier, since multiple people can work on the same project without overwriting each other's works. In this tutorial, we'll use Git in a simple way. To clone, download code from an online repository. The most common place where code is shared is GitHub, which you can think of as the library where all these projects live. So now we have a foundation built on 3 pillars: virtual environments, your organized toolboxes with the right versions of Python and libraries, IDEs or integrated development environments, your workspace for writing, editing and running code, and version control, Git and GitHub to track changes and access shared code. With this framework in place, let's move on and see how to get everything running on your Windows machine. Hi everyone, so in this video we'll set up a minimal developer environment for bioimage analysis using Python. We'll install Miniforge, Git for Windows and Visual Studio Code in that order. Okay, let's dive right in. First, we'll start with Miniforge. Miniforge is a lightweight distribution of Python that's easy to set up and works perfectly for scientific computing and bioimage analysis. It gives us access to a package manager called Conda, which helps manage Python libraries and dependencies. This is crucial because bioimage analysis often requires complex libraries that need to be managed effectively. So first we'll go to the Miniforge website and download the latest installer for Windows. We just scroll down and download the Windows installer. Now we'll run the installer and follow the prompts. We just have to make sure to check the option to add Miniforge to your system path during installation. So now we are in the installer. Click Next. I agree to the terms of usage. And then it's recommended to install it just for you. Just use the default path. And very important, add Miniforge 3 to my path environment variable. Then I also register Miniforge 3 as my default Python. Okay, now we hit next and we should be ready. Once it is installed, we'll open a terminal and type Conda version, and then we should see the version of Conda that is installed. This confirms that Miniforge is ready. I'll open the Miniforge prompt. Then I like to pin it to the taskbar so then it's easily accessible next time. And we'll type Conda version. Now we can confirm that it's correctly installed. Next up, we need Git, and Git is a version control system that allows us to track changes to our code and collaborate with others. It's very useful when we want to manage our Python scripts and share our work with others. You'll need it to download code repositories from platforms like GitHub. So first, we'll go for the Git for Windows webpage to download the latest version. Then we'll run the installer and stick with the default settings for simplicity. One key setting when prompt, make sure Git from the command line and also from third-party softwares is selected. This will make sure Git works in your terminal. We'll open the installer. We might need to give it user access control and continue with the setup. Install it in the default path. We'll leave this as default. Hit next. Just leave this as the default editor. let Git decide, and this is the recommended option. Git from the command line and also from third-party software. Leave this as default, and since we are on Windows, we'll use the native Windows secure channel. This is as default. For simplicity, we'll be using the default command prompt or PowerShell in this tutorial, not Git bash, Minty. So when you finish the installation, you can open either command prompt or PowerShell to continue. We choose the Windows default console window. Leave this as default. Same thing, default. And enable symbolic links. Now we can launch Git bash to make sure the installation has completed properly. And if we type Git version, we can check that it's correctly installed. Then we can see that it's also accessible via PowerShell. Finally, let's install Visual Studio Code or VSCode. This is a powerful text editor that we'll use to write and edit Python scripts and Jupyter notebooks. It's lightweight, but packed with features like code suggestions, debugging, and support for extensions. Go to the VSCode website and download the installer for Windows. Now let's run the installer, and again, stick with the default options. Make sure to check the box that says Add to Path so you can open VSCode from your terminal. Accept the agreement. Leave the default path, click Next, create an icon if you prefer, hit Next, and install. Now we'll launch it, and we can see that we have correctly installed VSCode. Afterwards, we can install a few extensions in VSCode by searching for them in the Extensions tab. It's the icon with a few squares on the left. Then we are going to install the extensions for Python, for Jupyter Lab, and a few ones that I find useful. So we'll install Python, Jupyter for Jupyter notebooks. Then I like to install a code formatter. Just trust the publisher and install. And a couple of extensions to visualize CSVs and the indentations in your code. Finally, we will install IntelliSense for path autocompletions. So now we know that we have Git installed. We have also Mamba installed with a base environment. So if I type Mamba environment list, it's going to list just the base environment in which we are. And finally, if I type code, I can launch VSCode directly from the command prompt. At this point, and before continuing with the tutorial, please restart your computer so the changes can take effect. Also, I wanted to share a few clarifications before we continue. So normally, when you open the Miniforge command prompt, it shows the base environment as activated by default. It might not be the case for you. In order to fix that, first you need to check if it's disabled by default by using this command. And if there's a false in there, in order to activate it always, you just use this command. Another thing that you might have noticed is that I'm using either Conda or Mamba without distinction. So in different tutorials you'll find either people using Conda or Mamba. Conda is the package manager and Mamba is a different implementation in C++ that is faster at solving dependencies. So you can use them interchangeably. For example, to list the environments, Conda environment list, Mamba environment list. But whenever you're going to build a new environment, I recommend using Mamba. And if it fails, you choose the slower route using Conda. Another error that you might encounter is that upon trying to activate a new environment, there's a critical libmamba or Conda error saying that the shell is not initialized. For example, to fix it in the command prompt, you just initialize Mamba for the CMD using this command mamba shell init shell cmd.x, hit enter, and then you restart the CMD. You just close the current window and open a new one, and that should fix the issue. In order to create the first virtual environment, I'll use Robert Haas' tutorial on focal plane, and we'll just copy this command and paste it into the command prompt. What this is going to do is create an environment that is called Nuclei Analysis 2. I'll just change it because I want to have an environment called Napari with plugins. And inside this environment, this is the Python version that we will be using, Python 3.9. It's going to install Napari for image visualization, and the Bioimage is a plugin distribution. So it's a little bit similar to this concept of ImageJ versus Fiji. So Napari would be the equivalent of ImageJ, and the Bioimage will make it into something looking like Fiji, where you have a lot of the plugins that you need already installed. And then this is going to look for the packages in the channel Conda-Forge, which is maintained by an open source community. Then I hit enter. While this is processing, I'll show you a few tutorials that I will share with you and might be useful if you're interested in virtual environments and how to create them and delete them. I'll share them in the video description. So this is one on focal plane by Robert Haas. This is another one by Juan Núñez Iglesias. And then this is another Python environment workshop by Tali Lambert. And they are very interesting and very useful for you to go through. Finally, if you're interested in installing Miniforge in other systems like Linux or in your Macintosh, you can follow this tutorial by the Viapol group. Again, I'll share these links in the video description. If we go back to the terminal, now we see that it has found all the packages needed and it's going to ask you to confirm the changes. Then you just type Y, hit enter, and now it's going to start to download them and later on install them.
A few moments later.
So now that the transaction has finished, we can list the environments by typing mamba environment list. And we see Napari plugins in there. And to activate it, we just type mamba activate Napari plugins using the same name. Now we are in the Napari plugins toolbox or virtual environment. And if I type Napari, this will launch a Napari window with all the plugins installed. And we can see it here. We see that it has plenty of useful plugins. And then we can open some test data. So Napari is correctly configured and ready to be used. Now let's clone our first repository. We are going to use as an example the Neurosec repository that can be found under my GitHub. You're just going to brain tissue nuclear segmentation. And what you do to clone this particular repository is copy this link up here. In order to keep things tidy, what I normally do is under your user, so if you go to your local disk, users, in this case the user is called Gastro, I just create a new folder that is called GitHub repos. So now that we have copied this link, we open the command prompt and type cd, choose directory, git, and then if you hit tab, it's going to autocomplete to GitHub repos. So now that we are inside, we are going to clone this repository by typing git clone and pasting this link. We'll just copy it, Ctrl C, Ctrl V, and now it's cloning it into this folder that we created here, GitHub repos, and we'll see the brain tissue nuclear segmentation folder in there. Now it's downloading the data, and after the download process is finished, we can type code or open VSCode by clicking on the icon. And if we say file, open folder, and navigate to our GitHub repos folder, we'll just choose this repository that we just cloned, you'll have to click the first time that you trust the authors, which is me, and I'm a trustable person. So now that we can explore the Jupyter notebooks that we will be using later on. So now if we click on select kernel and Python environments, we'll have access to the virtual environments that we just created, the Napari plugins and base. In order to run this project, we'll have to create our own virtual environment. In order to create the virtual environment that will allow us to run the code contained in this repository that we just cloned, we'll just scroll to the bottom until we find the environment setup instructions, and we'll start copying these commands into the command prompt from Windows. So I'll just open it, and first thing that we'll do is copy the environment creation command. Afterwards, we'll have to activate the environment and perform a few modifications using pip install so it correctly leverages GPU acceleration and multi-threading during CPU operations. After it has found all the necessary packages, you'll just hit yes to confirm the changes. This might take a while because on top of the packages, it needs to download CUDA from NVIDIA and QDNN for GPU accelerated tasks. Now it seems that it has finished. So again, we'll check that we have created the environment. We can see it there. So we have just performed this first step, which is creating the virtual environment with some of the packages. But now we'll have to activate it and start installing a few extra packages that are needed. Of course, TensorFlow, which will be version 2.10 because that's the latest supported version for Windows. So now it's downloading it.
A few moments later.
After TensorFlow is done installing, we'll install Stardist, this particular version. This should be faster. We installed GPU tools, which are important for training the Stardist model. Afterwards, EDT. We'll have to roll back a few versions, particularly Regna, NumPy, and Mamba. So as you see, I'm just copying the commands, pasting them here, and then hitting enter. And at this point, we'll have a virtual environment that is ready to be used with this repository. Now, if we go back to VSCode, we can see that we can load the newly created environment. And this will allow us to load the necessary tools to execute the code. Congrats! At this point, you should be equipped with the basic tools to continue on your bioimage analysis journey. If you like this type of content or have suggestions on how to improve the tutorials, feel free to get in touch or follow me on LinkedIn.